Chapter 1.5 Infinite Geometric Series. What happens as n approaches infinity if r is greater than 1 or r is less than -1? Let's try a couple examples. For the series 5 plus 10 plus 20 plus 40, etc. T1 equals 5 and r would equal 2. 10 divided by 5 is 2. 20 divided by 10 is 2, etc. Then sum of the first term would just be 5. Sum of the first two terms would be 5 plus 10, which is 15. Sum of the first three terms would be 15 plus 20, which is 35. Sum of the first four terms would be 35 plus 40, which is 75, and so on. And we see that the number continues to grow, so sum of the infinite number of terms would be going to positive infinity, growing forever and ever and ever as the n value continues to grow. Let's try this with an r value that's less than -1 and see what happens. We'll use the series -2 plus 6 plus -18 plus 54, etc. T1 equals -2, and the r value, 6 divided by -2, is -3. Then the sum of the first term is just -2. S2 would be the sum of the first two terms, which is -2 plus 6, which is +4. S3 would be 4 plus the third term, so 4 plus -18, which would be -14. Sum of the first four terms, S4, would be S3 plus the fourth term, so -14 plus 54, which is 40. And continuing on, we notice that the numbers are getting larger, but they're jumping back and forth between positive and negative. So the sum of the infinite number of terms would equal positive and negative infinity. The sum would jump back and forth between a very large positive number and a very large negative number. So these are called divergent series. A divergent series is a series with infinite number of terms and the partial sums do not approach a fixed value. So infinity is not a fixed value because it keeps getting bigger and bigger and bigger, right? So these sums are going to infinity, which means they keep getting larger or jumping back and forth between positive and negative infinity. So they're not approaching a specific value. A series is divergent if the r value is less than -1 or if the r value is greater than +1. What happens as n approaches infinity if r is between -1 and +1? Let's look at an example. We'll use the series 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1 over 128, etc. Then T1 equals 1, and R we can calculate. If we take the second term, which is 1/2, and divide it by the first term, which is 1, we get an R value of 1/2. S1, the sum of the first term, is just 1. S2, the sum of the first two terms, would be 1 and 1/2, so 1.5. S3, the sum of the first three terms, would be 1.5 plus 1/4. We can start to use our calculator here. So that should be 1.75. We have 1.5 plus 1/4. 1 divided by 4 in brackets is 1.75. Then S4, the sum of the first four terms, we would take S3 and add the fourth term. So just hit plus and then do 1 over 8 on your calculator. And that's 1.875. S5, add the fifth term, which is 1 over 6 to our last answer. So plus bracket 1 divide 16, I think I said 6, I meant 16, is 1.9375. S6, we want to add the sixth term, 1 over 32, to the last answer. So plus bracket 1 divide 32, close bracket, we get 1.96875. S7, add the seventh term, which is 1 over 64, plus bracket 1 divide 64, close bracket, is 1.984375. S8, last one, add 1 over 128, plus bracket 1 divide 128, close bracket, is 1.992185. So notice what our numbers are doing. We go from 1 to 1.5, 1.75, 1.875, 1.9375, 1.96875, 1.984375, and then 1.992185. So we are getting closer and closer to 2. So S infinity is 2. Our values are approaching 2. This is called a convergent series. Which is a series with an infinite number of terms, and the partial sums approach a fixed value. A series is convergent if the R value is greater than -1, but less than +1. If a series is convergent, we can find the sum of the series The sum of a convergent series is calculated by S infinity equals T1 divided by 1 minus R. Let's test this out for the series that we have here. T1 is 1 and R is 1/2. So S infinity equals T1 over 1 minus R gives us S infinity equals 1 divided by 1 minus 1/2. Then S infinity equals 1 divided by 1 minus 1/2 is 1/2. And S infinity equals 1 divided by 1/2. That's dividing by a fraction, so we can write that as multiplying by the reciprocal. We get 1 times 2 over 1, which just equals 2. So S infinity equals 2. The sum of the infinite series is 2. Determine whether each infinite geometric series converges or diverges. Calculate the sum if it exists. To determine if an infinite geometric series converges or diverges, we need to know the value of R. If R is between -1 and +1, so bigger than -1 but smaller than +1, then the series converges. If R is outside of that range, so if R is less than -1 or if R is greater than 1, then the series diverges. If it converges, it has a sum. If it diverges, it does not have a sum. So let's figure out the R value for each example. The first one, 1 plus 1 over 5 plus 1 over 25. R equals, let's take the second term, 1 over 5, and divide it by the first term, which is 1. That equals 1 over 5. And 1 over 5 is greater than -1, but less than 1. So our R value is between -1 and 1. Therefore, the series converges and has a sum. And we can calculate that sum using the formula. S infinity equals T1 over 1 minus R. In this case, that would be S infinity equals T1 is 1 over 1 minus R, which is 1 over 5. We can calculate that. 1 divided by brackets around the denominator, 1 minus another set of brackets around the R value of 1 over 5, close bracket, enter. And this is a nice decimal. If it wasn't, you'd want to write it as a fraction. So I can write it as a fraction. S infinity equals 5 over 4. Or we can write that as 1.25 since this is a terminating decimal and we don't need to round. If the question said round the sum to the nearest whatever, then you know that you want to write it as a decimal and round. But otherwise, keep it as a fraction unless it's a nice terminating decimal that is exactly equal to the fraction. B, the series 4, 8, 16, etc. We want to figure out the R value. R equals, let's take term 2, 8 divided by term 1, which is 4. 8 divided by 4 is 2. 2 is greater than 1, so we have the situation where R is greater than 1. That means the series is divergent and has no sum. Therefore, S infinity does not exist. That's all you write for your answer. If R is either less than -1 or greater than 1, the series is divergent, so there is no sum, so you just write S infinity does not exist. That brings us to the end of the Chapter 1 notes.